Okay, so lab we're doing today, guys, is pretty straightforward. Okay, at least like the lab report part. The collecting of data part is going to test your hand-eye coordination. So pick the person in your group with the greatest hand-eye coordination to be the whirler. Okay, the person who is going to whirl the rubber stopper around and around. Okay, someone is going to have to be a timer because the whirler can't do two jobs. They have to concentrate on not getting the rubber stopper in the head. Okay, that will be their one and only job. Right? And then another person will time, and maybe even a third person can count the rotations. Sometimes it helps to have all hands on deck. Okay, for this for the procedure part of this lab. All right, so what we're investigating here is the relationship between the radius of a circle and the speed at which the object travels in that circle. Okay, so basically we are looking at this formula. Okay, and we are going to just be testing its validity. Okay, seeing what that relationship is. According to the formula, okay, an increase in R should result in an increase in V. Okay, so that's what we're just trying to test. All right, so variables in this lab are the radius of the circular path, okay, and in this lab, that's what we're going to change. Okay, we're going to test different radii, because that's plural, you don't say radiuses, that's like hippopotamuses, okay, radii, okay, like octopi. So we're going to test different radii, and we're simply going to record the period of rotation, because we can't actually measure the speed. Okay? We don't have a radar gun, okay, that can tell us how fast the rubber stopper is moving. So we're going to record the period, and then we're going to figure out, calculate what the speed is for the different radii. Okay, everyone kind of following me there? So we kind of have more than one responding variable in this lab. Okay? We're directly measuring one thing, but we're using it to calculate another thing. So two things are changing. Okay? Now, we have to think about what other things could affect the speed of the rubber stopper, okay, as it moves around in the circle, because those things need to be controlled. Right? So we've got this. We know that we're looking for the effect on this, so that's not controlled. We know this is changing, so that's not controlled. Okay? We know that we're changing this one, so that's not controlled. Okay? But what are some other things that might affect V? Well, yesterday we learned about this formula. Okay? Radius is in there, and we already know that that's part of it. Okay? And that's what we're changing, so that's out. But there's a couple of other things in that formula that could affect the speed at which the rubber stopper is going to move around in the circle. So I would say those are probably things that need to stay the same throughout the lab. Okay? That's all I'm going to say about the design. I think you guys can get it from there. Okay, remember, each one needs to be identified and explained. So manipulated, identify, explain. Responding variables, both of them. Identify and explain. Okay, 3 control variables. Identify, explain. All right, you'll get a third one here in a minute. Okay, you'll figure it out. Okay, for the hypothesis. Okay, so we want an if, and then statement. Okay, the if part should talk about what the theoretical relationship is between R and V. Is something wrong with that one? Okay, the and part, as always, describes the experiment, which you're going to see in a minute because I'll demo it. Okay, and then the then part, okay, needs to predict your results. And that can include, okay, not just what's going to happen to V, but also the period. Okay, because obviously that's what we're actually measuring, and then we're calculating V from that. Okay. All right, so the lab is going to use an apparatus like this. Okay, so you're going to have these plastic tubes that, some of the edges are a bit rough, or because I'm not very handy, straight. Okay, like some of them go like this because they don't cut very well. Okay, so try and pick one that's, you know, like that one's not great, but it's better than the bottom. Okay, and maybe that's a source of error that might be useful later. Okay, and what you're going to be doing, okay, is getting this thing to whirl around and around without holding the string. Okay, that's the key. If you hold the string, you don't know what the centripetal force is, because you're going to just hold on to it, and then you can whirl it around as fast as you want, okay? Because the string won't go anywhere. So you've got to hold a specific radius, okay, with just the centripetal force here, okay? Now the centripetal force is from this thing, so that might help you with another control variable. There's something that's acting on this little thing right here that's helping you out, okay? So as I whirl that around and around, okay, as the whirler, my job is to make sure that the radius stays the same. And the way I'm going to do that is I'm going to mark on the string the various radii. Okay, so that would probably be the 20 centimeter mark right there. And so if I'm whirling this around in a circle with a radius of 20 centimeters, I need to make sure that that mark is where I can see it. Now, whoever used this one didn't do it right, because I don't want the mark at the top of the tube. Where is the mark better? Like, I have to measure the radius from the top of the tube, because that's where it's going to be the radius. But watch this problem. I have a radius of 20 centimeters, and I'm checking to make sure I stay at 20 centimeters. It's fine when the radius is 20 centimeters, but what problem do I have when it gets to 40? I can't see the mark anymore, because now I have to hold it higher. So I'd say you're better off to mark below the tube. Measure here to 20 and put your mark down here so that when you're whirling it, you can watch it. There, I've got it. Okay, I'm just going to pull it down a little bit. Okay, now I've just got to hold it there and make sure that it doesn't go in or out. Okay, is it going to be perfect? No. Okay, if I go too fast, it'll go up. If I go too slow, well, it might not come back out. Okay, so you got to kind of find that. This is what I'm saying. It's going to test your hand-eye coordination. You got to find that happy medium, and you got to make the circle like this, horizontal. People kind of get like chicken a little bit, and they start doing this. Is that a horizontal circle? That's a vertical circle. Is the speed constant there? No, it's not. Okay, so we got to make sure we're doing it like this, okay, and get it to that mark and hold it there. Okay, hold it there, hold it there, hold it there, while your partners are counting the revolutions and timing. If you want goggles to do this, I will go get some. There's no shame in that. Okay, I have had a person get a black eye doing this. Now, that person couldn't walk and chew gum at the same time, but safety first. Okay, if you want goggles, I will go get some and I'll bring them in here, and there's no shame in taking a pair. Okay, just because, yeah, I have had that happen. Now, also, this person never listened to instructions and had way more mass on the bottom of this than they were supposed to, which means that it was going way faster than it was supposed to, okay? And they had it coming, okay? When they got it in the eye and came to the room, I got it in the eye. I looked at their apparatus and went, because that's exactly what they deserved. Okay, yeah, so follow instructions, read the instructions. You only need 100 grams on the bottom of this. Okay, 100 will be the number. Okay?
How much did the guy have on the bottom?
Kilogram. Okay, it was ridiculous how fast this thing has to go with a kilogram of mass hanging on the bottom. Okay, yeah.
Imagine explaining that. How'd you get your black eye? Oh, physics experiment.
Yeah, he probably tried to sell it that way. My explanation would have been didn't listen. Yeah, failure to listen, failure to follow instructions. Other things I'm not allowed to say. Yeah. Okay, so that's going to be the procedure. Now, when you're doing this, okay, like I would say just speed up until you get to the proper radius and then kind of just hold it there as best you can. I see people try to do this all the time. They pull it to the right number and then and they're trying to get it going. It's not going to work. Okay, and that's how you get it in the head by accident. Okay, just speed up until you get to the right radius and then hold it there, okay, as best you can. And it's going to take a little bit of practice, okay, and that's okay. Practice a little bit before you start taking data so you've got the hang of it. It gets harder the longer it is. Spoiler alert. Okay, so you'll need, the apparatuses are already kind of half built, like there's rubber stoppers with strings already attached to them. You just have to run the string through the tube and put the 100-gram mass on the bottom. Okay, so the trials that you're going to be running, okay, are going to, so we're going to have a 20, now on this sheet and on your sheet, the radii are in centimeters. What do you want them in?
Meters.
0.2 meters, 0.3 meters, 0.4 meters, 0.5, and 0.6. Those are the only radii you're going to do. Okay, and you're going to obviously spin it around. Okay, safety goggles, I'll go get them. Okay, 100-gram mass. Okay, and then this is what you're going to do. So you're going to have your radii here, and you're going to time it twice for each radius, and then you're going to average the 2 times, just for accuracy's sake. Okay, because there's a lot of judgment and human kind of limitations in this. Okay, so you're going to time 20 revolutions. So one person has to count. Okay, so when you get it, when the whirler gets it going, they'll say, okay, I've got it. And then the person counting will tell the person timing, go. Or maybe it's just one person, but okay, and you say go, and then you're like, okay, 1. And always pick the same spot, right? So when it's coming like right past the whirler's head, that's a good marker. Okay, so 1, 2, 3. Okay, you got to time 20 of them. Right? So you're going to write those times in here, then add them together and divide by 2 to get your average time. Okay, then that's the time for 20 revolutions. We want the period, which is the time for
1 revolution.
1 revolution. Okay, so we're going to take that and we're going to divide by 20, and we're going to have the period. And then we can calculate the speed, okay, from there. And we will simply use that formula to do it. Okay, everybody with me on that? All right. Okay, so that's in the analysis here. Now, in the analysis, you're basically, most of the analysis is just getting this chart filled in. Okay, so what I would want to see for any analysis question that has a calculation, show me one calculation, just so I know what you did, just in case something goes wrong, I can figure out what you did. Okay, you don't have to show me every single calculation. So when you're saying, like for question number 1 here, for each trial, average the 2 times. Just show me the first one. Show me what you did. Do it the same way every time. Okay, same thing for number 2. Now, for number 4, okay, identify the force that acted as the centripetal force and determine its value. I'm sorry, this didn't copy over here. So using this equation, so that's this equation right here, okay, calculate the speed and put it in the speed column. Identify the force that acted as the centripetal force. Okay, spoiler alert, it is not the tension in the rope. I mean, it is, but something's putting the tension in the rope. Okay, without that little thing I was pointing out before, there would be no tension in the rope. Okay, then you're going to plot a graph in Google Sheets of velocity versus radius. So just make a Google Sheet, put radius in the first column, speed in the second column, graph it. Okay, and then you're looking for the relationship between radius and speed. Okay, just tell me what it is and explain why you think that, and you're good for that one. Conclusion, copy paste your hypothesis. Did your data do what you thought it would do? Okay, and then 2 sources of error and ways to fix them. Okay, now remember, I said there's judgment error. That's different from human error. Human error is I didn't do it right and didn't fix it. Okay, judgment error is I was counting and I was using a moving object in my reaction time. That's not human error, that's a limitation. Okay, and that's different. Does everyone follow the difference? Okay, human error is I screwed up and didn't fix it. Okay, this is I had to do it this way, that was a limitation. Okay, and it affected the experiment in this way. Everyone follow? Okay. All right, questions from you guys? All right, so the radii are 20, 30, 40, 50, 60. Okay, do those radii and you are good. So 2 trials for each one, average them. Okay, shouldn't take too long once you get the technique down. Okay, just make sure you've got lots of room. All right, now all of the stoppers are tied on. Oh, but not that one. The rest are. Okay, and the knots should be pretty good, but it might not be a bad idea to check them. Okay, give that rubber stopper a good pull. Okay, make sure it's not going to come off. okay? And then run the string through the tube, okay? And put 100 gram mass on the bottom. So everything he needs up here, send one person from your group up to get everything, and we'll get started.